Let's talk about how we can extend the idea of the angle addition postulate to help us solve more complicated problems. In our previous video, we learned about the angle addition postulate for the first time. We learned that it says that the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. In other words, little part plus little part equals the whole thing. In this video, we're going to extend that concept to a more complicated diagram, but the concept remains the same. Instead of just having two angles inside of a bigger angle that you can add up to get to the total, we'll have three or more angles that we can add up to get to the total angle. So for this diagram, the angle addition postulate would look like this. The measure of angle ABD, that's this angle, plus the measure of angle DBE, so that's this angle, plus the measure of angle EBC, that's this angle, equals the measure of angle ABC, so the entire angle. So instead of just adding two, we're in this case adding up three angles that make up the entire angle. Let's take a look at an example. We're asked to calculate the measure of angle VWX. VWX is the entire angle, which as you can see is made up of three different angles. One measures 43 degrees, one of them measures 102 degrees, and then one of them is only 12 degrees. According to the angle addition postulate extension, we could write this equation. The measure of angle VWZ plus the measure of angle ZWY plus the measure of angle YWX equals the measure of angle VWX. And again, like I said in the previous video, you don't have to write this sentence every time, but it is what your brain should be thinking about when you are solving a problem that looks like this. Let's plug in the numbers from our diagram. It would look like this: 43 plus 102 plus 12, 43 plus 102 plus 12, that equals measure of angle VWX, and if I add up all three of those numbers, I get my answer of 157 degrees. So as you can see, it's very similar to what we learned about in the previous video. It's just kicking it up a notch. Instead of only having two angles that we're adding together, we'll have three or more. Our next problem asks us to calculate the measure of angle DEG, and we actually saw a problem pretty similar to this in the previous video that a lot of students will just be like, okay, so DEG, here it is, it's 153, and done. But 153 is attached to this arc. The arc tells you that the 153 degree angle measure applies to angle DEF, because the arc ends on ray ED and ray EF. So it's this angle that 153 degree angle measure is referring to. So unfortunately our answer isn't just 153, done, move on to the next one. We'll have to do a little bit of math to figure this one out. So I'll set up my angle addition postulate and plug in what I know. What is the measure of angle DEG? Well, I don't know, that's what I'm looking for, so I'm just going to leave it as the measure of angle DEG. What is the measure of angle GEF? GEF is 54 degrees. What's the measure of angle HEF? HEF is right here, it's 73 degrees. And then like we said, the measure of angle DEF, this whole thing, is 153. So filling in my numbers, my equation turns into this. So to solve for the measure of angle DEG, I would need to subtract 54 and subtract 73 from 153. So 153 minus 54 minus 73 gives me the measure of angle DEG, which is 26 degrees. We also learned in the previous video that you can use this concept even if it involves algebraic expressions, and it's no different for more complicated problems like this one. In this case, we actually have four angles that are labeled, and we're told in the directions that the measure of angle ABC is 180 degrees. In other words, it's a straight angle, which you could tell just by looking at the diagram. You're allowed to assume that those points are collinear. In other words, it's going to add up to 180. So I'm going to add up all four of those angles and set it equal to angle ABC. In other words, 4x plus 3x plus 2x plus 1x equals 180. Let's combine those like terms of 4x plus 3x plus 2x plus 1x. That gives me a total of 10 x's. Divide both sides by 10 and I find out that x equals 18. However, it didn't ask me to calculate the value of x, it asked me to calculate the measures of the angles. So I'm going to have to plug in 18 to 4x, and 18 to 3x, 18 to 2x, and so on, and I would get these as my answers. The measure of angle ABD is 72, DBE is 54, EBF is 36, and FBC is 18. As always, it's a good idea to check your answer by adding all four of these up. Do you get an answer of 180 when you add up all four of those numbers? Yeah, you do. So we must have done it correctly. Alright, our last example here is the most challenging, but it's the same concept as the other ones that we've seen so far. But before I set up my angle addition postulate equation, I want to label my diagram with the information from the directions so that I'm looking at a complete picture. It tells me that the measure of angle LJM is 73, so I'm going to go ahead and put a 73 right here at the vertex of angle LJM. Alright, my angle addition postulate would tell me that the measure of angle IJL plus the measure of angle LJM plus the measure of angle MJK would be equal to this whole big angle IJK. So let's plug in each of these expressions. First, I need the measure of angle IJL. Well, IJL has two different expressions in it. Which one do you use? Yep, 5x plus 5 degrees, because that's the one that's at the vertex of that angle, whereas the 13x minus 6 is attached to this arc, which implies is the measure of angle IJK, the whole thing. So let's plug in our numbers. We have 5x plus 5, plus LJM is 73, plus MJK is 2x, is equal to the entire angle 13x minus 6. So let's solve by combining like terms. 5x and 2x is 7x, 5 and 73 is 78. Then I'll subtract 7x from both sides. Then I'll add 6. And finally I'll divide by 6 to get a value of 14 for x. But of course that's not our final answer. We are asked to calculate the measures of all of the angles, so I need to plug in 14 to x here, and x here, and x here to figure out those missing angle measures of 75, 28, and 176. So now you know how to solve all types of angle addition postulate problems, whether they are simple or more complicated like the ones we saw today. In our next video, we're going to extend this to a related concept, which is angle bisectors. See you then.